Effects of living in space: 1 year, 10 years, and 50 years. Have you ever pondered how spending time in space would change your body? And, if it did change you, would everything go back to normal once you returned home? It's a question scientists at NASA have been contemplating, and to find answers, they performed a space study on twin brothers. One of the twins was astronaut Scott Kelly, who spent a year on space on the International Space Station, while his identical brother, Mark Kelly, spent that time on Earth. Researchers compared them to see the effects of spaceflight, and they found striking differences between the twins. Welcome to Bender Solarium. Join us as we travel through space and explore the effects of living in space for 1 year, 10 years, and 50 years. As we know, identical twins share the same genetic material. Any differences between the twins would be due to their environments, not genetics. Here is what researchers found about what happens to your body if you stay in space for a year, 10 years, or 50 years. First, living in space modifies your gut bacteria. Researchers monitored the complex community of microorganisms living inside both Mark and Scott throughout the study. They found that during his time in space, Scott's microbiome, the bacteria in his gut, drastically changed. Some good news is that it doesn't seem like there's a need to go on a diet in space. That's because you're going to lose some of your overall body mass in space anyway. Researchers found that Scott's body mass reduced by 7% during flight due to improved exercise and controlled nutrition while on his mission. So it's like being on a diet, but you really don't have any other choice. Another change they found was in Scott's chromosomes. It turns out your telomeres get longer in space. Telomeres are the protective caps on the ends of chromosomes, and as we age, these telomeres get shorter. But shockingly, while aboard the ISS, Scott's telomeres became elongated, although it's hard to know at this stage what, if any, effects that might have. During Scott's time on the ISS, he experienced about 146 millisieverts of ionizing space radiation, which is equivalent to about 10 to 15 abdominal CT scans. Researchers think some of the DNA damage they noticed was due to radiation. Living in a microgravity environment also impacts the way thousands of individual genes are expressed. Some good news is that vaccines seem to work just fine in space. Scott got his flu shot while on the ISS, and his immune system responded the same way as Mark's did. Mark got his vaccine at the same time on Earth, so your immune system is still capable of doing its job after spending a year in space. Spending too much time in space can cause vision problems. Researchers found that the blood supply to the back of Scott's eyes swelled, and parts of his retina thickened, which can cause vision problems. Moreover, Scott's carotid artery, the large vessel that supplies blood to the brain, became thicker during the flight. In the meantime, Mark's artery wall did not grow any thicker. Researchers also discovered a slight drop in Scott's mental performance upon his return to Earth. But does that mean that staying in space for a year makes you sick and less smart? Definitely not. Most of the changes observed in Scott during his stay on the ISS went back to normal within 6 months of his return to Earth. But this is all based on just 1 year in space. If we are to become a spacefaring civilization, we will be experiencing much more than this. For instance, a return trip from Mars would take 3 years. How would that affect the human body? To find out, NASA already has plans to send more astronauts into space on longer missions. Garrett Reisman, a former NASA astronaut, has logged 107 days in space. There are a few immediate side effects, he says, when you first experience microgravity. The first thing you really feel is that you feel kind of sick. You don't feel very good those first couple of days. It's kind of like being airsick or seasick. We call it space adaptation illness. Your vestibular system, your organs that deliver information to the brain about your rotation and your acceleration, they're not working that great without gravity. Without gravity exerting force on your body, your bones and muscles start to break down too. In fact, bone density drops by over 1% per month. By comparison, the rate of bone loss for elderly men and women is around 1% to 1.5% per year. And because it doesn't take much effort to float through space, your muscles lose strength and endurance pretty quickly. You have to work out every day. Garrett says that they scheduled 2 hours a day pretty much every day while he was on the space station for working out. What he found was, if you do enough resistive exercise, you can halt the effects of bone loss and muscle atrophy. Without gravity pulling them down, fluids pool in the body, tricking it into thinking it's carrying too much water. As a result, astronauts have to pee a lot. This makes it easy for them to get dehydrated and develop kidney stones. So, you have a shift in your fluid balance. A lot of the blood volume that normally is down in your legs ends up towards your head, and your chest kind of puffs up, and your face puffs up, and you can see it. So what does all this mean for the future of space travel? Well, a trip to Mars would endanger astronauts even more than those on the International Space Station. They would face increased shifting of gravity fields, higher levels of radiation, and longer travel times, all of which would compound the negative effects of space on the human body and mind. The major issue to deal with is the radiation. We just don't know how exactly what radiation does to human beings. What do gamma rays or heavy ions do to human tissue? We don't really know. Right now, NASA and other research organizations are working to build better technology that protects astronauts against these dangers. So maybe one day, humans can make it to Mars. Space is a risky, unfriendly place not especially suited for human life, yet astronauts are sent to the International Space Station every year. From exposure to high levels of radiation to surviving in microgravity conditions, space can be a tough place to live. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time here on Solarium.